Good morning. My name is Airán Francés. My thesis is related with Blackbox nonlinear modeling and stability analysis of electronic power converters in DC microgrids. First, I'm going to explain why we think that microgrids in general and DC microgrids in particular are important context for this analysis. The main characteristic of a DC microgrid is that there is a lot of variability that comes from the use of renewable sources. So the power generated is variable. The state of charge of the batteries are necessary in this application. The consumption of the users, that is very variable as well, and the presence or not of the grid. In order to cope with all these variable conditions, it's very useful to use power electronic converters to interface each of the elements. These power converters provide dynamic decoupling between the different elements and also provide the possibility of controllability of the different elements in the microgrid. So a system level controller can be designed to follow the reference given by an upper layer intelligence with an optimization algorithm. So in this context, the variability means that the small signal approximation for power converters is going to be compromised. So nonlinearity can be present, and it's also useful in this application to use commercial converters. So we are going to need to use a black box approach because the information about the converter is not going to be available. So the black box approach is to take the power converter, make some perturbations to the converter, and then from the response of the converter to this perturbation, we can obtain a small signal model. If the converter has nonlinearities, we can repeat this process in another operating point and therefore build a collection of small signal models that we can integrate in a nonlinear model, in this case called the polytopic model. In this thesis, we have proposed several methods to improve the accuracy and the possibility to account for different scenarios that we can see in DC microgrids. For example, the dynamic weighting function instead of a classical static weighting function in order to improve the transition between small signal models, how to include the effect of system level controllers, how to include different operation modes in the converters when they change from voltage mode to current mode, and also how to interconnect individual black box models in any desired power architecture. So at the end, we obtain a large signal model of the microgrid where we can study what happened in the microgrid in all these different scenarios. So some of these proposals have already been tested experimentally during a short stay in Denmark in the Aalborg University, taking advantage of their expertise with hardware in the loop and real-time simulations. We identified some commercial converter that they had, and using hardware in the loop, we changed the controller, and in real time we were able to compare the behavior of our black box model with a real equipment in different scenarios. So that's all. Thank you very much.